This is a demonstration of how the responses API, recently released by OpenAI, can be used to automate the detection of anomalies in the procure to pay process. The scenario is that a user gets this purchase invoice. It is a scanned document in the form of an image. It contains the contract number, the supplier ID, and all the line items which a supplier has dispatched to the company. These have to be validated against a contract information which resides in the backend system. So in this case, I have the contracts information in an Azure SQL database. Um, so both the headers and lines information is available here. And this information is accessed through an API, through a logic app, which is what you see on the screen. So this is what the logic app is: a business process orchestration tool on Azure, which in this particular case, this particular orchestration can be invoked using HTTP trigger. Okay, and then this is the schema that it expects as an input. It takes the contract ID from the purchase invoice and the supplier ID from the purchase invoice in the scanned document, and then that information needs to be passed in the HTTP trigger. And the next time the flow involves it running a T-SQL on the fly based on the input that it received in the HTTP trigger, and then it returns back the contact information after querying the database that I just showed you. So this is one aspect of it. The other aspect is that there are certain business rules that need to be considered when the anomaly detection needs to happen. So I have just tried to create a very simple scenario or a simple set of rules, all described in natural language. It says, for example, that the invoice date in the purchase invoice should match that in the contract. The contract should be in vogue, etc., etc. So this information resides as a document, okay, and I'll be using the vector database in OpenAI to store this information in the form of vectors. And you may be aware that OpenAI provides a turnkey capability to vectorize documents, and then you upload, create a vector index, you upload documents, and then automatically it gets indexed and gets ready for you to search upon. So the last part is that, like I said, the invoice document is uploaded by the user in the form of an image. So we need to have a vision capability. In this case, I'm using GPT-4o's multimodal capabilities to look over this particular document, and based on instructions, extract the contract number, supplier number, with which it can call the logic app that I described, and also extract the line items here, which need to be verified for alignment with the contract data in the database. So that is a summary of what the whole process involves. Now let's get down to how this particular solution is going to handle it. So like I said, I'm using the responses API of OpenAI. Um, it uses a couple of hosted tools. For example, it uses the vector database. So in fact, if you notice here, sorry. Yeah, so this is the it has, like I said, it has got access to a couple of hosted tools. The first one is the vector database that is created. In fact, I have used the SDK to create a vector store and then populate it with the document that I just walked you through. So that is something that I've already done behind the scenes, and then I have used the vector database created thereby to in this particular step. The next action is the function calling. Like I said, Azure Logic Apps can be called over a HTTP trigger and through a REST API call. And then, so here is where I have described this particular invocation. I'm sorry, just and the name of the custom function that I've implemented is retrieve contact. So by the way, this is not a out of the box action capability in a responsive API. So I had to create my own function, and then through function calling, I'm calling it via the responses API. Okay, so in fact, if you look at the tools.py, this is where I have implemented the function which calls the logic app, and then it takes the contract ID, supplier ID, and then returns the data set comprising of the contract information. Now getting back to the main code here. So this is the tool list that I'm actually feeding to the system. And so here is where actually I'm loading the invoices from my local file system. So in this case, I'm choosing this invoice 002, which I have created with this intent that it should have a lot of discrepancies which will come out over the course of this particular use case execution. These are the instructions. So in fact, like we know of the system prompt with the chat completions API, in the responses API, you don't have that. You have something called instructions. Okay, so this is where I'm passing this instructions, because you can't expect an end user to pass these instructions, because these are internal and probably determined by the organization. So this goes as a part of the instruction to the responses API. And what the user merely states is the fact that they have uploaded a purchase invoice image, and then they would like to uh, use the agentic system that I'm demonstrating to detect any anomalies if they exist in the whole process. So this is where you actually use the responses API of OpenAI. I'm using the GPT-4o model, the instructions, which is the replacement of the system prompts that we know of from chat completions API. And this is the user input message, the list of tools that actually we provided it with. And then I'm just saying that parallel tool calls is false, because I want this to be run sequentially, with the output of one being fed to the as input to the other. So once the runs happen, uh, all the tools that can be invoked on the hosted actions can be done automatically from the responses API. For example, the search, and then we also need to use GPT-4o to extract the contract ID and supplier ID using the vision capabilities. So for that, they're all hosted tools, and they're called directly by the responses API. But only for the logic app invocation, it's a custom function that I've implemented. So the responses API delegates control to you here, saying that, hey, I think I came across this particular tool call, which I think you're better equipped to run. So I extract the name of the function from the tool call response, from the um, responses API, and then with that I'm dynamically calling the function, executing it, and then passing the arguments that the responses API provided me with. So the logic app invocation happens here, and then the responses that I get from it is again fed back to the responses API, and then this is where I continue the call to the response API, saying that, hey, here goes the response from the logic app containing the contact information. Just go ahead and complete the use case in its entirety. Okay, and then the whole process completes, and this is where actually the response gets printed out. Okay, now let me run this quickly. So like I said, I'm passing this particular invoice number as input. Okay, so it has invoked the logic app. It has obtained the contact information, and now it is executing the rest of the steps required in the procure to pay validation. And you'll notice that the logging that you see is only for the function calls, because this happens locally on my machine, whereas the other tool calls are happening in the cloud. Okay, so you don't get any trace of that in your application logs. There is some, of course, an ability for you to stream these responses, where each and every action that it took, there is an event that it emits, which you can actually capture. And then if you want to log it, or you want to integrate it with some downstream system, that also could be done. But for simplicity's sake, I'm not doing that here. So you see that it has completed the whole job. It has what it has done is it taken the invoice image, it has extracted the contract ID, supplier ID, and also the line items from it as instructed, and then it made the call to the logic app, and then it came back with this contact information. It also queried the vector database. It obtained what those business rules are. And in the light of those business rules, it is actually comparing the invoice and the contract data to see if they are matching. And then obviously, like I said, it comes up with a lot of discrepancies that it observes, and then gives me a detailed report. Okay, so let's just go to the logic app, and I should be able to see it's 10:48. Yeah, so if I refresh this now, I should see the run that happened just now. Yeah, this is the one. So when I click upon it, you'll notice that the call had indeed come through here. And then, so this was the T-SQL that it ran on the database, and then it sent the response back to the response API call. Okay, so that concludes this demo.